Hello everyone. Yesterday I have updated the results of assignment 3, and you can take a look of the results. And for assignment 3, know that the output of the program, there is no space between the English letters. So if there is some space between English letters, then this is regarded as output format error. And assignment 4 is announced, and I will explain the assignment 4 later. And the due date is 3 weeks later. And in previous week, we have learned how to use pointers for accessing array elements. In this slide, introduce the array, the relationship between array and the pointers. And I use this example to illustrate the relationship between array and the pointers. First, I declare an array. This array has 5 elements, and I declare a pointer. And next, I print array name, and array name is actually the same as the address of the first element. And I also print the value. I also print the value of the pointer. And then I assign array name to pointer. So this statement will make the pointer point to this array, and the value of this pointer is actually the address of the first element. So the first 2 lines are the same. They are the same address, because the array name is the same as the address of the first element. And the third line, I print the value of the pointer, because the pointer is not initialized, so its value is random. Its value is unknown, so this value is random. And then I assign the array name to the pointer. And after this statement, the value of the pointer becomes the memory address of the first element. So the fourth line is the same as the first and the second line. You can also do some practice. For example, you can print the value of PTR plus 1. And what is the value of PTR plus 1? And we know that if PTR is this number, then PTR plus 1 is this number. And the difference between the two numbers is 4. And why the difference between the two numbers is 4? Because here we use pointer addition. PTR plus 1 is pointer addition. And here plus 1 means not plus 1 byte. Here plus 1 means plus the size of one element. And here this array, each element in this array is an integer. So here plus 1 is plus the size of one integer. And the size of one integer is 4 in this machine. So PTR plus 1 is actually plus 4 bytes. And the 4 bytes is the size of the integer. We can assign array name to the pointer, but reversely, we cannot assign the pointer to the array name. Because the array name is a constant pointer, we cannot change the direction of a constant pointer. So if you try to change the direction of a constant pointer, we will encounter syntax error. So I add this line. I try to assign PTR to the array name, and the compiler issues incompatible types in this line, because the right hand side is integer pointer, while on left hand side is an array, and this behaves like a constant pointer. So this line is syntax error. If you try to assign a pointer to the array name. And then next, we will learn dynamic arrays. What we have learned is called a static array. And the limitation of static array is that we must specify the array size first. For example, we cannot declare array like this because we do not specify the array size. But if you give initial values, this initial value implicitly specify the array size to be 5. So if we want to use the static array, then we need to specify the array size. Another use some students declare array size, declare an array like this. He let the array size to be a variable, and for example, the size variable is 10, and then he used this variable to be the size of an array, and this is fine. This is fine. But later, he changes the value of size to be 20, and he think the size of the array should be also 20. In fact, the size of the array will not be changed. If you print the size of the array, you will find the size of the array is always 40, and 40 is 10 times the size of integer, and each integer is 4 bytes. So 4 times 10 is 40. So even though you let the array size to be a variable, but the change of the variable will not affect the array size. The array size is determined by its declaration, and after this time, the size of array is fixed to 40 and will not be changed. So this line will not change the array size. And in fact, we do not recommend writing program in this way. We recommend to use named constants. So it is better to write program like this. And therefore, the limitation of static array is that we must specify size first. And therefore, we must estimate maximum size needed. And for some scenario, this is okay, but for some scenario, this is not okay, because this approach wastes memory. For example, I declare array to store the scores of students, and I don't know the exact number of students, and therefore I need to estimate the maximum size, the maximum number of students, and this approach might waste memory. So a better approach is to let your array can grow and shrink as needed, and this is called dynamic array. If the array can grow and shrink as needed, then this array is called a dynamic array. And later we will show we can use the new operator to declare a dynamic array. And for this example, we cannot change the size of the static array. Its size is fixed. So we cannot grow or shrink the size of this static array. And to create a dynamic array, we can use the new operator. For the syntax is like this. We use new int. Int is the data type of the element. And after int, we add a bracket. And inside the bracket is the array size. And the new operator will return a pointer. Will return a pointer pointing to the allocated memory. And we assign this pointer to ARRPTR. And then this pointer behaves like an ordinary array. So we can process the dynamic array like an ordinary array. We can use a for loop and use this syntax to access the elements of an array. And after using this array, we can, if we want to return the memory, then we need to use delete, the keyword delete, to return the memory allocated. And after the keyword delete, we need to add a bracket. If you omit the square bracket, then you will only return the memory of one integer, because if you omit the bracket, the compiler will return only the size of one integer. You can compare this line with the delete operator in this slide. In this slide, we return the memory we return the memory, and the memory size is one integer. And if we want to return the memory of a dynamic array, then we need to add a bracket after the delete operator. And if you don't delete, if you don't return the memory, then your program will cause a memory leak. And you can search the result of memory leak. And the memory leak will cause your the memories of your operating system to be exhausted, and in the end, there will be no free memories in your operating system. So if you create dynamic arrays, you must remember to return the memory you allocated. Otherwise, your program will program will cause memory leak. And we have finished the first two parts of this chapter. And the third part is about user-defined data types. And we will revisit this part after we learn how to define our own data types. So we will omit this part first, and after we learn user-defined data types, then we will return to the third part. And in the previous chapter, we know dynamic arrays can grow and shrink, but it is not convenient to manually create and delete dynamic arrays. So in the standard template library in C++, layer is one data type called vector, and this data type implements dynamic array. And we can, if you want to use dynamic array, you can use vectors rather than manually create and return the memory. So using existing functions is a better approach. So in this chapter, I will introduce how to use vectors. And this data type is defined in standard template library and abbreviated as STL. And you can look the contents of the textbook. STL is in chapter 19, and I extracted the vector part here. And if you are interested in more data types or more related functions, you can take a look at chapter 19. And first, we learn how to initialize a vector. You can think vector as an array. So declare a vector is like to declare an array. And method one, to declare a vector, we use the predefined word vector. And after the predefined word is a angle bracket. And inside the angle bracket is the data type of the element. And suppose here we suppose the element is integer. And we can use the equality sign to give initial values. And this is like array initialization. The initial value is inside the braces. And in this example, I declare a vector of integers. And to use this data type, we need to include the vector library. And after the declaration of this vector, we can access this vector like ordinary array. So we can use for loop to access the elements of this vector. And we can call this function dot size. We can call this function to get the size of the vector. And the next method 2 gives another method to initialize the vector. We can let the vector to be we can declare a vector without initialization. So this line, for this line, we did not initialize the vector. We only declare a vector variable. And later, if we want to add elements, we can call the function pushback. We can use pushback to insert elements into this array. And you can also try to do some practice. For this example, I declare a vector without initialization, and then I print its size. Then you will observe that its size is 0 because we do not give initialization. And then I call the function pushback. Each pushback can only insert one element. So I made 3 function calls. I insert 3 elements, and then I print the size of the vector. And the size of the vector becomes 3 because I have added 3 elements. So this way is very flexible because you don't need to specify the size of the vector in the declaration. So this method is very flexible. And next, let's see method 3. We can use existing array to initialize a vector. And for example, we have an array which has 3 elements. And suppose we want this array to be the initial value of a vector, then we can use this syntax. We declare a vector. Then after the vector is parenthesis. And this is like a function call. And this is known as constructor. This is known as a constructor. And we will learn constructor in later chapters. And this function has 2 inputs. The first input is a pointer pointing to the first element we want to copy. And the second input is another pointer. So here is the pointer addition. And the second input is a pointer to the memory location of the last element, the next element of the last element. And we can see a figure about this. This statement. And method 4 is to initialize a vector with some existing vectors. And I use the first we declare a vector with 3 elements. So the size of this vector is 3 because it has 3 elements. And later I declare another vector, her vector, and I use my vector to be the initial value of her vector. And here the size of her vector is also 3. And in this statement, we use the function called begin, and we use the function called end. And here this function will return iterator. Iterator is like a pointer. So this function call will return the begin function will return a pointer pointing to the first element of the vector. While the end function will return a pointer pointing to the next element of the last element. We know that here end is not pointing to the last element. End is pointing to the next one. What? And you might wonder why end is not pointing to the last element. This is for we can change this function call. For example, we can change end to we can change end to the function call end to begin. And we can use +3, and this is like pointer addition. So this pointer is pointing to 3 elements after the first element. So end is so I changed this example to the one in the slide. And this vector has 5 elements, and I want to declare another vector, her vector, and I want to copy this vector, copy my vector as the initial value of her vector. And the first input is a pointer, and the first input is a pointer pointing to the first element you want to copy. And the second element is also another pointer. And suppose we want to copy 5 elements, then you use +5 here. And the size of her vector is 5. And if you only want to copy 3 elements, then you simply change +5 to +3. And now the size of her vector is 3. So my vector dot end is like So my vector dot end is equal to my vector dot begin plus my vector dot size. You can verify this. You can verify this fact. For example, I print this is the comparison. I compare my vector dot end with my vector dot begin plus my vector dot size, and the result of this comparison is true. So its value is 1. So my vector dot end is actually equal to my vector dot begin plus my vector dot size, and this plus is not ordinary addition. This plus is pointer addition. So it is the pointer. It is the pointer my vector dot begin plus some integer returned by my vector dot size. And you can refer to this figure to know what is begin and what is end. Begin is a function, returns a pointer, and the end is also a function, returns another pointer. The exact name is not a pointer, it's iterator, because we are dealing with a vector or not an array. So the exact name is iterator. But the concept of an iterator is like a pointer. So sometimes I will call the iterator a pointer. And we go to method 5, and suppose we want to initialize a vector with 5 elements, and the 5 elements are all ones. Then we can use this function code. For example, I use this line to initialize a vector with 5 elements, and the elements are all ones. And you can change the initial value. For example, you can change it to -1, and you can also change the number of the. You can also change the vector size. And this function call initialize my vector with 3 elements, and the value of each element is -1. So this line is very convenient. You don't need to write for loops to initialize a vector. With this single line, you can initialize a vector with initial values. And this slide compare the initialization of array and the initialization of a vector. On the left-hand side is the method to initialize an array, while on the right-hand side is the method to initialize a vector. And let's take a break for 10 minutes. And later we will have a quiz, or we will use the Rubio to take a quiz. Hello everyone. We will have a quiz, and raise your hand if you need a paper. 画一下，一半给我，一半给我，一根一张，好，也可以，可以。最好一张张发，因为不太够。30 seconds left. And I will close this question. The second question is also about pointers. And 30 seconds left. And I will close the second question. 30 seconds left. I will finish this question. Please write down your name and your student ID. And I will collect the papers. You can forward your paper to the first row. And let's see the answers of the quiz. And the answer of the first question is option 3. And let's see this question. First, I declare an array with 3 elements, and then I declare a pointer ptr, and its initial value is the memory address of the first S element plus 2. And suppose the memory address of the first element is 1234. And what is the value stored at ptr? And we know that ptr is a pointer, so its value is memory address. And its value is given by this expression. So we need to compute the value of this expression. And this expression is actually pointer addition, because it is a memory address plus some integer. So this is pointer addition. And here plus 2 means plus the size of 2 elements. So and each element is an integer. So the correct result is 1234 plus 2 times size of int, because for pointer addition, 2 means the size of 2 elements. So here is 2 times size of int, and because each element of the array is an integer. Let's see the next question. The answer of this question is 15. We need to compute the value of star ptr1. And here star means dereference. we dereference the pointer ptr1. So here ptr1 points to integer v1. So star ptr1 is the value of v1. So we need to compute the value of v1. And the v1, from this line, we see that v1 is v1 plus star ptr2. So we need to, and the initial value of v1 is 3. So it's 3 plus star ptr2. And we need to compute star ptr2. And ptr2 points to integer v2. So we need to compute the value of v2. And the value of v2 is in this line. v2 equals v2 plus 5. And the initial value of v2 is 7. So 7 plus 5 is 12. And the value of 12, the value of v2 is 12. So star ptr2 is 12. And the 12 plus v1 is 3. 12 plus 3 is 15. So the value of star ptr1 is 15. And this is some basic example of pointers. If you are not familiar with the usage of pointers, you can review the slides. For this question, the correct answer is option 2, syntax error. Let's see this question. I declare an array, and the next I declare a pointer ptr1, and I also declare another pointer ptr2. Then I assign star ptr1 to ptr2, and this will cause syntax error. And because on the right hand side is an integer, because this star is dereference. Dereference pointer means to get the value it points to. So on the right hand side is an integer, while on the left hand side is a pointer. So the data types are different, and therefore this equality will cause syntax error. It is important to know that a pointer is a data type. This data type is different to integers, so we cannot directly assign an integer to a pointer. And if no further questions, we will return to our slides. Let's see assignment 4 first. And I post this assignment. I have posted this assignment on the course website. And let's see this assignment. We need to write a program to compute the semester grades of students. This program first read the number of students, and assume that there are at most 10 students. and then the program will read 6 scores for each student. This number 6 is fixed, and each score is an integer, and this integer ranges between 0 and 10. And this program need to compute the semester grades of each student and determine the number of the most difficult quiz. And in the following is the definition of the semester grade of each student. The semester grade of each student is the average of the 4 highest scores. Let's see one example. Suppose the user enter the number of students is 3, and then he need to enter 6 scores for each student. So the first row is the 6 scores for the first student, and the second row is the 6 scores for the second student, and the third row is the 6 scores for the third student. And if you enter 10 students, then you need to enter 10 rows. And then we need to compute the semester grade for each student. For student one, we need to find the 4 highest scores. So here are 6 scores. We need to pick the 4 highest ones, and which are 10, 6, and 4. So the 4 highest scores are 10, 6, and 4. And then we need to compute the average of the 4 numbers. And the sum of the 4 numbers is 30, and the average of the 4 numbers is 7.5. So the semester grade of the first student is 7.5. And similarly, you can compute the semester grade of the second student. We need to sort the 6 numbers, and you will find the largest numbers are 9, 8, and 6. And the sum of the highest numbers is 32, and the average of the 4 numbers is 8. After computing the semester grades of each student, we need to determine the most difficult quiz. And here I suppose the quiz number begins from 1. So the 6 numbers corresponds to the score of the 6 quiz. So for the first quiz, there are 3 scores. For quiz 1, the 3 scores are 4, 9, 5. For quiz 2, the scores are 1, 2, 0. For quiz 3, the scores are 10, 6, 3. And the most difficult quiz is the one that produces the smallest sum of scores. And if there are two quiz of the same difficulty, then you need to report the one with the smaller quiz number. For example, if quiz 1 and quiz 2 gives the same sum of scores, then you need to output quiz 1 because quiz 1 is the smaller quiz number. And for this example, number 2 quiz is the most difficult one because the sum of quiz 2 is 1 plus 2 plus 3, which is the smallest. And you can verify this fact. And I provide a code template. You can modify this code template to finish this assignment. And actually, you only need to modify the definition of two functions. So for this assignment, you only need to modify the compute semester grades function and the display hard quiz function in the code template. If you open this template, then you can go to the definition of the two functions. So this is the definition of compute semester grades. And you need to enter your code here. Such that the program outputs the correct behavior. And you also need to modify the definition of display hard quiz. And you need to enter your code here to find which quiz is the most difficult one. And do not modify other functions. Or do not modify read student grades or display semester grades because this will affect the program output. And this will cause the evaluating program not able to judge your solution. And I also suggest do not modify the main function unless you know what you are doing. If you know what you are doing, you can try to modify the main function. And I also give more input-output samples. After you finish your program, you can use these input-output samples to test your program. You can use copy and paste. You can copy the text as the input. And you may need to sort an array. And to sort the array, you can use this function. And we have introduced this function in the slides. So if you don't know how to use this function, you can see the slides. And let's take a look at the code template. And this program is bigger than the previous assignments. let's take a look at the main function. In the main function, first I declare an integer variable which denotes the number of students. And the second variable is a two-dimensional array. And this array is to store the grades of each student for each quiz. So this array is two-dimensional. The first dimension is the number of students, while the second dimension is the number of quiz. The number of quiz is fixed to 6. So I declare this number to be a named constant. And the number of students, and here I give the maximum number of students. The maximum number of students is 10. So I declare a named constant, max students, and its value is 10. But the actual number of students might be less than 10. So the actual number of students is this one, is number of students. This number is less than 10. And then I write a function to let users input grades. So I read a function, read student grades, and I pass the two-dimensional array as the input. And the second input is the number of students. And if you take a look of the definition of this function, the function definition is here. And first, I use cin to read the user inputs and save the user inputs in the number of students variable. And then I write a nested for loop to read the user inputs and save the user inputs in the two-dimensional array, student grades. And you can assume that the inputs are always legal. You can always assume the user inputs are always legal. And we also notice that here we need to use call by reference. Because we add AND operator here, we use call by reference for number of students. Because we let the user input the number of students, and after this function call, after the function call of read student grades, we still need to access this value. We need this value. This value is in the later function calls. After reading the after reading the student grades, then I declare a one-dimensional array. This one-dimensional array is to store the values of the semester grade of each student. So if there is 6 students, then the semester grade will have 6 scores for each student. And then I call the function compute semester grades. And this function will compute the actual value of semester grades for each student. And its input is the two-dimensional array, student grades, and the number of students. And this function will store the result in the third input. This function will store the semester grade in this variable, in this one-dimensional array. So you need to implement this function. This function is the definition of this function is here. Its input is a two-dimensional array, and the number of students. And we need to save the result in the. We need to save the result in the third input, semester grades. So below I use a for loop to access. I use a for loop to access the grades, the scores of each student. Then you do some computations to compute the semester grade of each student and save the semester grade in this variable. And this is the first. This is the first function you need to implement, and after you compute the semester grade, then you can display the semester grades with this function. And this function is given by the code template, and you don't need to modify this function. If you are interested, you can take a look at the definition of this function. This function displays the semester grade of each student. And finally, we need to implement display semester grades. Finally, we need to implement display hard quiz. And the input of this function is the two-dimensional array, student grades, and the number students variable. And you need to determine which quiz is the most difficult one from the two inputs. And the definition of the most difficult quiz is given here, and also the definition of the semester grade of each student is also given here. You need to follow the definition to implement the two functions. And the purpose of these assignments is to let you know how to organize your program. If you see the structure of this code template, you will find that this program use a lot of functions. This program defines three functions, define four functions, and you will find writing program in this way will make your program more readable. You can know the intention of this program from the function names. You don't even need to read the definition of each function. You can know the purpose of each function from its function name. So using function is a very important skill. Using function is a very important skill. This skill can improve the readability of your program, and this skill also makes your function easier to maintain. And if, for example, if you want to change the way how users input the two-dimensional array, then you can modify the definition of the read student grades function. So it is also easier to maintain. Demonstrates how to write functions and how to design your function declarations. If you take a look at the function declaration, and you will find this requires the knowledge of call by reference and call by value, and when to use the const modifier. For example, if you want to declare a function read student grades, and you need to determine whether to insert the const modifier. And for this example, we cannot use the const modifier, because if we use this const modifier, then we cannot modify the value in the function definition. So we cannot add the const modifier in this function. And also you need to determine whether you want to use call by reference or call by value. If you use call by value, then after this function call, you cannot access. If you use call by value, then after this function call, you cannot access number of students the user have input. So here we must use call by reference. And also for this function, compute semester grades, here we can add the const modifier, because we do not modify the values of student grades inside this function. So we can add the const modifier. And this is some protection to prevent that we change the value of the two-dimensional array. And here for the second input, number of students, and we use call by value. We don't use call by reference. You can also use call by reference, but for this function, we don't need to use call by reference. We can use call by value. And you can take a look at this code template to learn how to define a function and how to communicate informations between these functions. So a bigger program will require you to learn how to use functions. It is okay that you don't use functions at all. You can also write all your statements inside the main function. But this approach is not recommended, because this approach is only suitable for small programs. If your program consists of 1,000 of lines, then it is very difficult to maintain such program. So the due date of assignment 4 is 3 weeks later, and we also we will have the assignment 5, and assignment 5 will be announced in December 20. And let's take a break for 10 minutes. everyone. Let's return to our class. And we have learned how to initialize a vector. And in this slide is the comparison of array initialization and vector initialization. On the left-hand side, there are two methods to initialize an array. You can use this syntax to suppose we want to declare an array and with 5 elements, 1, 1, 1, 1, 1 as initialization. We can use method 1, or we can use a for loop to initialize the array. And for vector, we can use method 1, and you can use this this function. This is a constructor. You can use constructor to initialize a vector VEC to have 5 elements, and the values of the 5 elements are all ones. And you can also use method 2, use a for loop, and use the pushback function to insert elements. Which version of initialization do you prefer? If you want to write programs, you will choose which methods? Obviously, using for loop use for loop. You need to type more words, so it is slower to use for loops. It is better to use like this statement or this one. And for small array for small vector, we can use this statement. We just directly gives the initial value of each element. But if you have a lot of elements, for example, the array size is 1000, then it is not suitable to use this style. And you can use the vector version. The vector version is more flexible because if the size of the vector is changed, you only need to change the first input. So the method 1 of vector is more flexible because this version, it can deal with arbitrary size of vectors. And the next slide, on the left-hand side is the examples to initialize the elements to be zeros. And there are 3 methods. For example, we want to initialize an array with 5 elements, and all elements are zeros. Then we can use this statement, or we can use method 2. Method 2 only give one element, but according to the C++ rules, the remaining 4 elements will be initialized to zeros. So method 2 is equivalent to method 1. And we can also use a vector. And we can use this function call to initialize a vector with 5 elements, and the value of each element is 0. And on the right hand side, now suppose we want to initialize the elements to be 1. For example, suppose we want to declare an array with 5 elements, and the value of each element is 1. Then we can use this method 1. And we can also consider method 2. And in method 2, we only write, for method 2, we only insert a single element. And the syntax is legal, but its semantic is not what we want, because the semantic of this line means we initialize this array with 1, 0, 0, 0, 0. Because according to the C++ rules, the remaining 4 elements will be initialized to 0, not once. So for array method 2, its semantic is not what we want, because we want to initialize all elements to be 1. But method 2 only initialize the first element to be 1, and the remaining 4 elements are zeros. And we can also use vector to initialize its element. And the function call is very easy. You only modify the second input. You modify the second input to be 1. Then the value of each element will become 1. So this example shows the flexibility of using vector, because no matter the value you want to initialize, you can change the second input to be the value you want to initialize. But for array, you can only initialize all values to be zeros. If you want to change all values to be ones, you need to write a for loop to change the value of each element. In the next slide is the vector assignment. This is very similar to vector initialization. First, suppose we declare a vector as this one. And this vector has 5 elements, so its size is 5. And now we can assign this vector to another vector. Also, in this example, I give my vector as the initial value of her vector. And note that we cannot do this for array. We cannot directly assign one array to another array. But for vector, we are allowed to directly assign one vector to another vector. And this is very convenient and intuitive. So using vector is more convenient than using array. And the second method is you can declare her vector first without initialization, and then later in the second line you assign my vector to her vector, and this is equivalent to method 1. And we can also use the assign function. We can call the assign function, and the first input is the location you want to assign. The first is the first element you want to assign. It is similar to this is similar to the one in the initialization, in the vector initialization. So my vector dot begin returns a pointer to the first element of my vector, and my vector dot end also returns another pointer, and the 2 pointers specify the range we want to assign. So the 2 vectors, the 2 pointers specify the range of my vector we want to assign to her vector. And after this assignment, the values of her vector will be equal to the values of my vector. And you can also use the following statement. The results are the same. The results are different because this vector has 5 elements, and for this assignment we only assign the first 3 elements. And you can also use method 4 to assign a vector of 5 elements, and the value of each element is 1. And again, you can do some practice. You can use the online IDE or the code blocks to practice how to initialize or how to assign vectors. For this example, I declare a vector, my vector. I declare my vector to have 5 elements, and I also declare another vector, her vector, and because I do not initialize this her vector, so the size of her vector is 0. And then I use the assign function. I assign I assign my vector to her vector, and then I use a for loop to print the values of each element of her vector. And we see that the values of her vector are 1, 2, 3, 4, 5. And you can also change the range of pointers. For example, you can change begin to begins plus 2. And you can see the difference you can see the difference of the program outputs. Now the program only outputs 3, 4, 5 because begin plus 2 points to 3. So the assignment begins from the third element. So this assignment only assign 3, 4, 5 of my vector to her vector. So now the values of her vectors are 3, 4, 5. And you can also change the second input. For example, I change the second input to be my vector dot begin plus 3. And this is a pointer addition. So its memory address is 3 elements after the first element. So this statement will assign the first 3 elements of my vector to her vector. So now her vector becomes 1, 2, 3 because I assign the first 3 elements of my vector. And in the next slide, introduce how to access elements of a vector. And we already know we can use the bracket to access the element of a vector. And there is another option. We can use the at function. We can use the at function to access the element of a vector. The at function has one advantage. The advantage is that we can the program can check whether the index is valid. For this example, I declare a vector with 5 elements. But I use a for loop. But know that this Boolean expression has some problem because the index can be 5. And when the index is 5, then the index is outside the legal range. So when the index is 5, this expression will cause runtime error. This expression may cause runtime error. But if you compile this program, you will not encounter any error message, because the compiler will not check whether the index is outside the legal range. But if you use the at function, the at function will check whether the index I is in the legal range. And for this program, when I equals 5, then this program will throws an exception of out of range. This means the index is outside the legal range, and the program will terminate immediately. So we can use at to check whether the index is within the legal range in runtime. This is done in runtime because we are running the program. But if you use the bracket, and the compiler will not throw an exception, although the index is outside the legal range. So it is recommended that you use the at function to replace the bracket, because the at function can detect whether your index is within the legal range. This is a protection. This can prevent you to write. This can prevent your program to lead to runtime error. So if your program using expression like this one, and the I is outside the legal range, then your program will cause runtime error. But you don't know. The mistake will be found until some particular input or when your program is tested in a different machine. So it is very difficult to find this type of error. Below is another two function to access the elements of a vector. You can call front, and the front will return the first element of the vector, and the back will return the last element of a vector. you can learn you can practice how to use this function. For example, I print the first element of my vector, which is 1, and you can also call the front function to obtain the first element. And the next, I print the last element, which is 5, and the corresponding index is 4. And you can also call the back function to get the last element, which is also 5. And you can also call the size function. The size function will return the size of the vector. And in this example, size is 5. And for the index of the last element, we need to minus 1. So 5 minus 1 is 4. And we get the value of the last element. And the next slide shows how to iterate over a vector. And we already know we can use a for loop to access the elements of a vector. But there is one difference. Previously, we used integer to declare the index. And you can also use size t. Size t is one data type to declare the index. Use size t is more precise because integer can store negative values. So you can use size t. Size t is more precise. But it is also okay if you use integer to declare the index. And for method 2 is the range-based for loop. And I will skip this one. If you are interested in method 2, you can take a look at the textbook. Method 2 does not require the use of index. It can directly access the elements. For method 3, method 3 use the iterator. Iterator is like a pointer. We can use the reference operator to access the value of the element of a vector. So for this example, we can use iterator to print the value of my vector. In this example, I write a for loop, and I use the iterator to print the values of my vector. And first, I call the begin function, and this function returns a iterator to the first element. And in each iteration, the iterator is added by 1. And this is like pointer addition. This plus is like pointer addition. And the Boolean expression checks whether iter is equal to this iterator. If yes, then the for loop terminates. And to obtain the value, we use the dereference operator. This is like we use the dereference pointer for we use the reference operator for a pointer, and this will get the value where iterator points to. In the next slide is one example, and this example has a problem. And can you find where the problem with this example? This is from the assignment of one student. So this is a real case. I found this problem from the solution of one student. At the first sight, it seems okay, and we can try to compile this program. And there are no error messages, and you might think the program is okay and no problems, but actually this program can cause runtime error. This program can cause runtime error. The reason why there is no error message is because sometimes this is okay, but sometimes this assignment will cause runtime error. And can you see where the problem is? If you want to detect this problem, you can change the bracket to the at function. Then when we compile and run, we run this program. When we run this program will terminate because this line causes throws an exception out of range, because the index is outside the legal range. Because we initialize vector 2, but vector 2 does not. But vector 2 is empty, so the size of vector 2 is 0, and therefore the legal index for vector 2 is none. It's none because vector 2 is empty. So when the size of vector 2 is 0, any any non-negative integer I is out of range. So this assignment will cause runtime error. And you can try to print the size of vector 2, and you will find the size of vector 2 is 0. And when the size of vector 2 is 0, the legal range of index I is none. So we need to fix this problem. You can initialize VEC2, or you can, for example, I can initialize VEC2 to be a vector with 5 elements, and each element, the value of each element is 0. And there is also another solution. Another solution is to use pushback. So we can declare VEC2 without initialization. But when we want to insert element into VEC2, then we need to call pushback. So another solution is to use pushback. If you declare VEC2 without initialization, and you want to insert elements into VEC2, then you can call pushback. This function can dynamically allocate memory space and delete memory space. So this function can dynamically grow vector 2 or dynamically shrink vector 2. So the legal way to insert elements into VEC2 is to use the pushback function. And we know that if you want to protect your program, you can use the at function instead of the bracket, because bracket will not report runtime error. Only at will report the out of range exception. This is a common mistake for using vectors. And about the exception, when we compile this program, and suppose the index is outside the range, then the program throws an exception. And this is a C++ feature. And the exception is introduced in chapter 18. Actually, you can handle the exception thrown by C++. For example, if the out of range exception is thrown, then you can write some code to catch the exception and do something to handle the exception. But this is more advanced. So if you are interested in this topic, you can refer to chapter 18. And if you do not handle exception, your program will terminate immediately. And let's see the next slide. Suppose we want to add one element to the end of vector, we can call pushback. If we want to delete the last element from vector, we can call popback. If we want to clear the vector, or we want to make the vector empty, we can call the clear function. And if you want to delete one or multiple elements, you can call the erase function. If you want to insert one or more elements into vector, you can call the insert function. The next page contains some examples. For example, I declare a vector with 5 elements, and if I push back 1 and push back 2, then 2 elements will be appended to the vector. So now the vector has 7 elements. And now if I call popback, then the last element 2 will be deleted, will be popped. So now the vector becomes, now the vector has 6 elements. And the next, suppose I want to erase the first 2 elements, then I can use this function call. I can use this function call to erase the first 2 elements. And after this function call, the first 2 elements, 5 and 6, will be removed from the vector. And now the vector becomes 7, 8, 9, 1 after this function call. And now suppose I want to insert an element 10 in the beginning of this vector. So I specify the location I want to insert. And suppose the location is the beginning of the vector. And after this function call, 10 is inserted in the first element of this vector. So the vector becomes 10, 7, 8, 9, 1. And now suppose I want to insert 3 negative 1s in the beginning of this vector. Then I can make this function call. And after this function call, 3 negative 1s are inserted in the beginning of this vector. You can change the statements to practice how to use pushback, erase, and the insert functions. And we already, the next topic is about the size and the capacity of a vector. Suppose the vector has 5 elements, then its size is 5. And the capacity of a vector means its memory size. The memory size must be larger than the number of elements. So to store 5 integers, the memory you need to allocate at least the memory size of 5 integers, and the capacity can be greater than size. The capacity can be equal to or greater than size. And I use one example to illustrate the concepts of size and capacity. First, I declare an array. This array is empty because I do not initialize. And then I use a nested for loop to insert elements into this vector. And the outer for loop has the index I. I begins from 0 and I begins from 0, and in each iteration the I is increased by 1 until I is less than 5. And the inner for loop layer is another index j. And this for loop, the inner for loop, will push back 5 elements into the vector. So after the inner for loop, 5 elements will be pushed back into the vector. And then we print the size of the vector and print the capacity of the vector. And this process will continue 5 times because of the outer for loop. So when I is 0, then after the inner for loop, the vector size is 500 because we push back 500 elements. And the capacity needs to be equal to or larger than the size. And the capacity is determined by the implementation of the vector data type. And suppose the value is 512. And time is up. So let's end here. Next time we will return to this topic.